All right, ladies and gentlemen, we are going to take it old school and do a screen recording. This is everything you need to know about the measurement section of our notes. The measurement section of our notes starts with unit conversions. Unit conversions happens when we use the SI system going from big things to small things and vice versa. They all have basic meanings to them. They all have basic meanings to them. They start with kilo, which means 1,000. That means 1,000. Then we go down to hecto, which means 100. Deca, which means 10. Then our base unit, the is our grams, meters, and liters. That's a base unit of 1. There we go, 1. And then deci, which is 0.1. Centi, which is 0.01. And milli, which is 0.001, or 1,000th. Centi being 100th. Deci being 1/10th. They are 10 times smaller than the previous. All of these functions in the SI system operate on bases of 10. On bases of 10. And a mnemonic where you can remember this is King Henry died with a capital D. And I do mean give it some spice and disgust, because that helps you remember. The is the base unit. Has 3 G's for grams, meter, and liter. So 1 G, 2 G, 3 G for grams, meters, and liters. Those are your base units. So King Henry died drinking chocolate milk. That's how you can remember it. It's called a mnemonic. Mnemonics are memory devices. They help you turn things where you can remember them easier. And for clarity's sake, this side in blue will be the bigger side. We're getting bigger as we go this way from the base unit. And as we move away from the base unit and go that way, we get smaller. We get smaller. The SI system stands for Système International System. It's a French word that helps us communicate. That's why we care. The SI system helps scientists communicate their findings and what they understand about their work. That way we all can better progress the human condition. And the SI system is used all around the world for everybody. That way someone in Belgium can know what we're talking about in the States and vice versa. And what's different about the science approach to the SI system is our units. These units are everything. That's what distinguishes science from math. Okay, the units are everything. Our numbers have strong backing. They're meant for something. They have meaning. They are amounts of liquid, number of atoms, anything in between. And how we utilize this system is a number-based. So you move with the decimal. And we all know from math class, or at least I hope we do. Let me get a different color going on here so we can see it. We all know that decimals exist behind every real number. So decimals exist behind every real number, and then we utilize that fact to move between the units. So I can move 1,000 milligrams back to grams by moving my decimal. And my ladder, this is my ladder, okay? So we start with what's given. That's 1,000 milligrams. So I'm starting at milli. And where am I going? I'm going to gram. So let's count how many jumps it takes me to get to gram. Here we go. 1, 2, 3. I land on my gram spot. So I move 3 places. Which way? Right or left? Left. So now we go 1, 2, 3. There we go for 1.0 grams or 1 gram. Easy breezy, beautiful. So now I'm going to go the other way from big to small. From 14 kilometers, that's a kilometer, back down to meters. So I started here at kilo. That's what's given to me. You always start with what's given. Then you move on down to where you're going. I'm going to meters. And then we move it down. 1, 2, 3. Keep going till I hit it. And I moved which way? Right or left? I moved towards the right. So there's an imaginary decimal right here that I move 1, 2, 3. Every hump will be a 0. 1, 2, 3. So you just fill in what you know. That was given to me, 14. I moved it 3 places, so 1, 2, 3. And again, you'll fill in those zeros. So that is 14,000 meters. And that makes sense because if I have 14 kilo anything, in retrospect to a meter, that is 1,000 times bigger. That is 1,000 times bigger. So then we can apply the same principles as we go through each of these examples. So if I have, I'm going to switch colors so we can see them pretty easy. If we're starting with a liter going to milliliter, well, a liter is a part of a base unit system. So we're starting here at the base. I'm pointing like y'all can see. We're starting here at the base with my pink dot, going to milliliter. So here we go, 1, 2, 3. That's 3 places to the right. So we got 1 liter, 1, 2, 3 places to the right. And that's 1,000 again. But we know milli is 1,000th of a base unit. So there's 1,000 units for every 1 base. Milli is way smaller than 1 liter. I hope you're with me. Milli is smaller than liter. Gram is bigger than milligram. So there would be less of a gram and more of a milligram. But you're talking about the same thing. The goal here is equivalence. 1,000 milligrams is the same thing as 1 gram. 14 kilometers is the same thing as 14,000 meters. And the same thing here. 109 grams, I'm going to change colors one more time because I have them and why not use them? And that way we can see. Let's go to this awesome green color. 109 grams. So I'm starting back here at grams. Then we're going to go to kilograms. All right, let's move it. 1, 2, 3 places. Which way? To the left. So there's always a decimal behind every real number. And unless you're given a decimal, you move it where it was given to you. But if it's not given to you, you assume it's at the end behind every real number, like it always is. We move 3 places to the left. So it's 1, 2, 3 places to the left. That leaves me, my decimal is now in the front of that number. So we got 0.109, which is 1,000 times smaller than 109. Together? But 109 grams is the same thing as 0.109 kilograms. And just because I'm evil and conniving, apparently, we're going to make these ones you-tries. You're going to try these on your own, at home, wherever you're watching these, and come back and see me for the answers. Now, let's talk about comparisons. Comparisons happen all the time in math, so let's use them to our advantage. We can use this metric system, or this SI system, to compare between what's bigger and what's smaller, but you have to be talking about the same thing. You have to compare apples to apples. You can't just go at it willy-nilly. You have to be talking about the same thing. You have to compare apples to apples. You can't compare things that are not equivalent. So let's turn them into the same thing using this ladder method that I've made a whole mess of up there. So I know that King Henry died drinking chocolate milk, where my is my base units of grams, meters, and liters. Here we go. Let's go to work. I got a centimeter and a meter. The thing in common they got is a meter, so I'm going to turn everything into a meter. That's just how my brain works. You can totally turn both of these into centimeters and live your best life, but I'm going to turn everything into a meter. So this one's already a meter. I ain't got to do nothing. This one's already in a meter. I ain't got to do nothing to it. I got some work to do here. I'm starting at a centimeter. Centimeter is the C. I'm going to a meter. So now I got to put it how many places to get to a meter? 1, 2. 2 places which way? To the left. Point behind it. 1, 2. 2 places to the left makes it now 0.56 meters. All right. So who's bigger? 6 meters or 0.56 meters? Well, in my head, and what I learned from math class, a meter, 1 is bigger than 0.1. So this one's bigger. On to the next. I got 7 grams and 698 milligrams. Well, the thing they got in common is a gram, so my brain says go to grams. So let's go to grams. That one's already in grams, so I got work to do with this one. I'm in milligrams, so I'm starting here. Now I gotta go to grams. So here we go. 1, 2, 3. 3 places which way? To the left. 1, 2, 3. That leaves me with 0.698 grams. Well, that doesn't help me a lot. So 7 is way bigger than 0.698. Are we seeing the trend here? I hope so. I need another color because why not? Let's do orange. So here we're going to do 7,000 grams versus 7 kilograms. Easy breezy beautiful. We can do this. The thing they have in common is a gram. I'm going to turn them both into grams. This 7,000's already in grams. Let's turn this 7 kilograms into grams. I'm starting here at kilo, and I'm moving to grams. 1, 2, 3. That's 3 places to the right. I assume there is a decimal place behind it. 1, 2, 3. 1, 2, 3. That's 3 zeros behind it, so that's 7,000 grams. Uh-oh. Those are the same thing. So 7,000 grams is the same thing or equal to 7 kilograms. That is the quick down and dirty version of using the metric system, or the SI system for metrics to convert between the two. This is called the ladder method of conversions. You are welcome to go on YouTube and find yourself some videos to help you get more practice and understand this fully, but the concept is the same. The King Henry died, drinking chocolate milk, is the ladder, and we're using the decimals to move in between them. Going to the left side if it's bigger, and going to the right side if it's smaller. All right? Now let's keep it pushing to what we were talking about with volume. These metric systems, or SI systems, were used to determine values in science, and then one of those values is volume. You have 2 different categories of volume: volume of a liquid and volume of a solid. Volume of a liquid is derived of a liter or a milliliter. mLs and Ls are all derivatives of a liquid. It happens in a graduated cylinder, because remember the word graduation or graduated. A graduated cylinder means measured. This is a measured thing. And you read these graduated cylinders based off of the meniscus. The meniscus is the bottom of the bubble. So in my picture here, I have a perfect picture that tells you how to read these graduated cylinders. You can't look at it from above because you're too high. You can't look at it from above. You don't get the right angle. You can't get too low below the table because then you can't see it straight and you're getting the wrong information. You want to be even with the table or at eye level to see the meniscus. That's how you read the graduated cylinder. You read it at eye level looking for the meniscus, the bottom of that bubble that forms when you pour liquid into it, okay? Anytime you read the bottom, you're getting the correct volume of that liquid. Or you can talk about a solid. The volume of a solid depends on its even structured sides. All right, the even structured sides of a solid help us do cubic centimeters. Anytime you see this lovely doodad, cubic centimeters, you're talking about a solid. You're talking about a solid. So I take my length times my width times my height to get the volume of a solid. Let's do some math. I'm giving you a cube here. I've asked you what the volume is. So I'm looking to do that right there to define what is the volume. So you pull out your handy dandy calculator. Let me get mine loaded in here. All right. So I said I'm doing length times width times height. Can I move you? Haha. Length times width times height. So here we go. Length being 8 centimeters times width being 10 centimeters times height being 9. Boom, bow. I get 720 what? What's my unit here? Well, centimeters, because everything's a centimeter, but how many of them, and I'm multiplying them together. So we have centimeters cubed for 1, 2, 3 versions of centimeters talking about the same object. That's where we get that from. Can I make you go away? Ooh, all right. Now, we can also do, these are for regularly shaped objects and easy liquids with nothing in them. But sometimes we got to get the volume of irregularly shaped objects or more complex systems that require some inference. So then we do volume by displacement. Displacement means to move something out the way. Think about when you sit in the tub. If you're going in the tub, as you sit in it, the water does what? The water in the tub rises. That's why mom always said, don't fill it too full because you're going to make a mess. Then she's going to hand you the mop and bucket and say, have a great day cleaning up your mess. So we don't want to make mom angry. We want to keep things copacetic and nice and keep peace. So then the same principle of the whole water moving up and down thing as things are introduced to it is displacement. That movement is the displacement. And we can do some basic math to see the volume of that object in relation to how it moves. So you need some information. I have a graduated cylinder in this picture here. I'm talking about this picture right here. I'm over here pointing like you can see. But this picture here, you got some information. You got it with, obviously, this is without the water. I then drop that yellow circular thing into it, and this is with the object in it. W/O is without, W/ is with, and I get some different numbers here. So I can clearly see that I'm given some information about the water level with and without the object in it. So without, I see it is 50 milliliters. And with the object, it is 60 milliliters. So now I want to see how much the water moved. To get the displacement, you need the difference. So we're going to subtract those. And let's see if my math is math. Then 60 minus 50 is 10 mils. So the volume by displacement of that object is 10 milliliters. So I can say the volume is of that little yellow circle thing is 10 mils. That's my volume of that irregularly shaped object. The same principle applies on anything. If you got a mystery substance and you want to figure out what it is, try to identify it, you can use volume by displacement to identify this mystery substance too. That's one of the critical ways we can assess information. And as we're assessing information and communicating our findings, you have to talk about conversion factors. Conversion factors are, in a sense, the same thing as what we have going on here with the ladder. How 7,000 grams right here was the same thing as 7 kilograms. That means they're equivalent and they can be converted in between the two. There is a way to convert them. Talking about the same thing. You use conversion factors all the time. You just don't know they're called conversion factors. For instance, 60 seconds is how many minutes? Yep. 1. 60 minutes is how many hours? 1. 365 days is a year. That's a really ugly one. There we go. 48 hours is how many days? 2. If I say go to the store and get me 12 cans of soda, and they say, sorry, we only sell it by the case, how many cases should you leave with? That's 1. You gotta be talking about the same thing. They must be equivalent of each other. Like, oh my goodness, I haven't seen you in 10 years. I can also say, oh my goodness, I haven't seen you in a decade. They're talking about the same thing. So their equivalence matters. Let's keep it pushing. And that's because all we can communicate with each other and me talking about the same thing and make accurate comparisons. And a crash course on the SI basics. The SI basics is when you're talking about mass, you're talking about anything base grams or derived from a gram. So kilograms, decagrams, milligrams are all derivatives of a gram. And they're used in lab to be found out by a balance. It can either be a triple beam balance, 3x means triple beam balance, a thing where you gotta go big to small and move all the little squares, or it can be a digital balance. That digital balance is the things we'll use in my lab, where you put the object in the middle, it does the work for you. For volume, you're going to talk about a liter or any derivative thereof. So milliliter, deciliter, centiliter. And they're used to find out with a graduated cylinder. Graduated cylinder, meaning that measured glass tube we'll use in lab. For length, you're talking about a meter or any derivative of a meter. So decameter, kilometer, any meter is length. Length is found out by a yardstick. And there's also some other fancier versions of stuff on wheels that we can use to walk out things. But the basic thing is a yardstick or a ruler. Time, when we're talking about time, the SI unit for time is seconds or any derivative of seconds. So millisecond, centisecond, that kind of thing. And it's used by a stopwatch. Or a CPO timer. And another you try is, what makes a CPO timer special? What is it? I'm going to give you a hint. It has to do with a photo gate. A photo gate. That's all I'm going to say. You're going to come back and see me to get the answer. Now, for temperature, the SI unit for temperature is Kelvin. And it is measured with a thermometer. Digital or old school. But what I'm curious is, does a thermometer measure heat directly? No. Good. No. It measures kinetics. That particulate motion, how my particles are zooming around in their little containers, living their best lives. Are they moving fast or slow? Faster moving particles make things hotter. Slower moving particles make things colder. And then we move on to another property of matter and science is density. Density is a unique part of matter where you can use it to identify pieces of matter based on this constant number. In my class, density is constant. Constants do not change regardless of temperature or pressure, or don't change very much. The only big example we can see it changing is in samples of water, which I'll go through my little circles here and give you some examples of water changing. But all in all, density will be constant for you. And as a derived unit, this derived unit means it's made up of two parts. A derived unit is the ratio of mass in relation to volume. Relationships to mass and volume. That's a derived unit. So we know masses are things like grams and volumes are things like milliliters or liters, okay? But when I talked about temperature having a minor impact, it has a very small impact. We see a lot in water. Here, I can tell you have a sample of water. In my little circles, I have the particle arrangement of water at varying temperatures, all right? But you can say what temperature is the densest by looking at how the particles are arranged. If you're dense, you're really, really tightly packed together, all right? You don't have a lot of space to move around. So this, option C, would be the coldest water because things are really, really dense and really, really packed together. And B is like lukewarm or room temperature water. And A is hot water. You can tell it's hot because I look at the relative space between the atoms. I got a lot of space in A, I got some space in B, but C, I got a lot going on in there. Everything is tightly packed together. And you can see this actually as you're swimming around in the last parts of summer here, swimming in the pools. As you dive deeper into the pool, you get colder because the more dense water sinks below. And we can use this property of how density sinks and stuff to identify how materials interplay with densities. If you're trying to figure out a density and you don't know it, but you know the density of like oil or vegetable oil, you drop the object in and see if it floats. If it floats, it's less dense. If it sinks, it's more dense. If it stays in the middle, it's the same density. So if you're floating, you're less dense. And if you're sinking, you're more dense. All right, ready? And we're going to talk about some calculations on how to calculate density. How to calculate density, you want to take it one part at a time. The formula, if you want to approach it from an algebra perspective, is density equals mass over volume. All right? Or you can do this fancy circle thing I got going on to help yourself out. If math isn't your thing, I recommend you use a circle. We know my units for mass is a gram. I know my units for density is a combination or a derived unit of mass and volume. And volume's typically a liter or a milliliter. So I need some kind of proportion to mass over volume here for my density unit. But we are good at what we do, so let's go to work. For my first example right here, I got 50 grams per centimeter cubed. I got no volume, and I got 10 grams as my mass. So I'm looking for my volume. But I got to remember every math equation needs to have a unit. You always provide, Mr. Cole, units. So I got to see what units to use, because I don't know. You just got a question mark there. You use what's given. Which one of these is a volume unit? That one or that one? Because I know density is a derived unit of two things, mass and volume. So and my mass is kind of given to me already. So I know grams is my mass, and this centimeters cubed must be my volume. So my volume has to be reported in centimeters cubed. But how do I do the math? All you gotta do is cover up what you're looking for. You cover up what you're looking for. In this example, I'm looking for volume. I'm gonna put my finger over volume and pretend my blue stuff doesn't exist. So in my mind, my big blue bubble right here does not exist, which leaves me with M over D. So I'm dividing here, M over D, so 10 divided by 50 gives me 0.2 centimeters cubed. All right. And do the same thing for the other one. You do the same thing for the other one. So I know I got a volume of 7 centimeters cubed, a density of 140 grams per milliliter. I'm looking for my mass. I'm gonna, like the same thing I did over here, I'm gonna move my blob over here to the M and pretend that M does not exist. Ooh. I wanna turn this, oh, okay. We just won't do that. So that does not exist. I'll just do it like this. My M doesn't exist anymore. It's not given to me in my problem. I need to figure out what to do about the rest of the stuff. So I'm left with density times volume. So here we go. We're going to do some maths. Density is given to me as 140. So 140, I'm going to type it in my calculator. Times volume, that's 7. 140 times 7 gives me 980. 980 what? It was given to you. It was already given to you. In your density thing down here, your density value, you're given grams and milliliters. So these should match. So 980 grams. That means Mr. Cole has a typo here. Let me fix my OCD right here, because no, absolutely not. Here we go. All right. That's how we do that math. Let's keep it pushing. I want to figure out my density, given 25 grams as my mass and 500 liters as my volume. Well, I'm going to cover up density here, just like we did before. Density no longer exists. My big blue scribbles right here does not exist to me. I'm covering it up with my hand. Now I'm doing some math. I got to do M over V right now. So my M is 25. My V is 500. Pull out my fancy calculator here. 25 divided by 500. That gives me 0.05. 0.05 what? I know density is a derived unit. Oh, that's cool. I need you to go away, though. Okay. A derived unit. So it's a derived unit of what? A ratio between mass and volume. So I put them all on there. Grams per liter. Easy, breezy, beautiful. But now, I don't always have to give you the fancy setups we just did where everything's nice, neat, and linear. I can give you word problems that you must use those literary skills to plug and chug information that you need. So here we go. What is the density of a piece of wood that has a mass of 26.4 grams and a volume of 25 centimeters cubed? All right, so let's take it apart. Easy, breezy, beautiful. What is the density? So off the bat, what am I looking for? Density. I don't have it, so I'm going to cover it with my hand here. But let's go back and finish and see what else we got. I need two pieces of information, a mass and a volume. So I have a piece of wood that has a mass of 26.4 and a volume of 25 centimeters cubed. I'm covering my D over here because I don't have my info. So I know I need a mass and a volume. So I'm going to do mass over volume here. Well, I'm given in my yellow, mass is 26.4 grams. And I'm given over here in my red that the volume is 25 centimeters cubed. Plugging and chugging and pulling that information from my word problem. I then put that same stuff in my calculator. Oh, that's not doing the things that I need it to do. Okay. Hello? Oh no. Okay. That'll work. 26.4 divided by 25 gives me 1.056. That's too many numbers. You can always in Mr. Cole's class round to 2 decimal places. So we're going to practice those rounding rules. 1, 2 decimal places. That 6 is going to make that 5 round up. So my final answer here will be my density is equal to 1.06 what? Grams per centimeter cubed. And that, ladies and gentlemen, is how you do density. Remember, they must always match what you're given. So always take your blessings when they come. Things are given to you. Use them. If you have any questions, you know how to reach me.